Have you waited for so long? Welcome back to Math Nood and Math Tuto. Once again, I am Mr. H, Mr. Rico A. Herrero, and this is our episode number 2. Did you know that there are 3 types of parallelograms? Yes, it's true. And in today's geometry session, we are going to dive deep into rectangles, rhombi, and squares. But do not be confused. Rhombi is just a plural term for rhombus. We don't say rhombuses, but rhombi instead if we are pertaining to more than one rhombus. Have you ever speculated about the difference between a rectangle and a square? Or wondered about what really is a rhombus? These words are used by teachers all the time, and we've gotten used to hearing them. But what do they really mean? And how can we tell the differences among these special quadrilaterals? Together, we are going to put our knowledge to the test and discover some amazing properties about these 3 special parallelograms. We're gonna use these properties and characteristics to show what's similar and what's different. Find missing side lengths, missing angles, and even perimeter. Are you ready? Here we go! First, it is important to note that rectangles, squares, and rhombi are all quadrilaterals that have all the properties of parallelograms.
Let us have a review of the different conditions and properties that guarantee a quadrilateral is a parallelogram. First, opposite sides of a parallelogram are congruent. Second, opposite angles of a parallelogram are also congruent. Third, consecutive angles of a parallelogram are supplementary. Fourth, the diagonals of a parallelogram bisect each other. Fifth, either diagonal of a parallelogram forms 2 congruent triangles.
The biggest differences in terms of their characteristics deal with their 4 sides and 4 angles. A rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is a parallelogram with 4 right angles and 4 congruent sides. Just be reminded that all of them are parallelograms, meaning all of the properties of a parallelogram are also true to them. But wait, there's more. Let's take a look at each of their properties closely. Let us start with rectangle. The following are the properties of a rectangle.
First, opposite sides of a parallelogram are congruent. Second, opposite angles of a parallelogram are also congruent. Third, consecutive angles of a parallelogram are supplementary. Fourth, the diagonals of a parallelogram bisect each other. Fifth, either diagonal of a parallelogram forms two congruent triangles.
And here are the characteristics that are unique to rectangle. All four angles are right. Diagonals are congruent.
Let us take quadrilateral QUAD as an example. Given that QUAD is a rectangle. If UE equals 21, what is the measure of ED? UE and ED are segments that joined to form diagonal UD. Remember that diagonals of parallelogram bisect each other. Since rectangle is also a parallelogram, thus diagonals of a rectangle also bisect each other. Hence, we could say that UE is equal to ED. Given that UE equals 21, therefore ED is also 21. On the same figure, if QU equals 13.5, how long is DA? By looking at the illustration, QU and DA are opposite sides of the rectangle. As a parallelogram, opposite sides of a rectangle are also congruent. Thus, QU is equal to DA. If QU equals 13.5, then DA is also equal to 13.5. Let us now take this problem. We are to find the measure of angle QUA. As you can see, QUA is one of the four angles of rectangle QUAD. And according to the properties of a rectangle, it contains four right angles. Thus, the measure of angle QUA is 90 degrees. This time, we are going to find the measure of angle UQA, given the measure of angle DQA of rectangle QUAD. By inspection, you will notice that these two angles formed one of the right angles of the rectangle when combined. Thus, the measure of angle DQA plus the measure of angle QQA is equal to 90 degrees. By substitution, since DQA measures 38 degrees, it will become, using addition property of equality, simplifying the results, therefore, the measure of angle UQA is 52 degrees. Let us have a little complex problem still in rectangle QUAD. Angles QAU and AEU are two angles of triangle. Recall that the sum of the interior angles of a triangle is equal to 180 degrees. Then, we will have, since AE and UE are parts of the bisecting diagonals of a rectangle which are congruent, we could say that triangle AEU is an isosceles triangle or triangle with at least two sides congruent. In our case, AE and UE are the congruent sides of triangle AEU. Applying one of the properties of an isosceles triangle, that its base angles are congruent. Thus, the measure of angle QAU is equal to the measure of angle AUE. Thus, by substitution, simplifying the resulting equation, by addition property of equality, therefore, angle AEU measures 130 degrees.
Just remember that aside from having characteristics of parallelogram, rectangle has also four right angles, and its diagonals are congruent. Let us discuss now other properties of a rhombus. Recall that rhombus is also a parallelogram. Thus, all of the properties of the parallelogram are also true to rhombus. But what makes it different from the other two special parallelograms are the following properties. All four sides are congruent. Diagonals are perpendicular. When we say lines are perpendicular, they form right angle which measures 90 degrees. Diagonals bisect vertices, meaning the diagonal divides the angle into two equal parts. Diagonals are not congruent. They only divide each other into two equal parts. Let us apply these characteristics of rhombus to quadrilateral ROSE.
First, let us find how long is OS given the length of RE, which is 15. Since ROSE is a rhombus, and we all know that rhombus is a parallelogram, thus, its opposite sides are congruent. Hence, RE is equal to OS. Therefore, OS is equal to 15. ES is also one of the sides of rhombus ROSE. Since rhombus has four congruent sides, therefore, ES is also 15. On the same illustration, let us find RS given that RH is equal to 15. As you can see, RS is one of the diagonals of the given rhombus. Since its diagonals bisect each other and SH is also 15, therefore, RS is equal to 30. On this problem, given the measure of angle RES, which is 100 degrees, we are asked to find first the measure of angle ROE. In this case, we are going to apply the property of the rhombus as a parallelogram that its opposite angles are also congruent. Thus, the measure of angle ROS is also equal to 100 degrees. Remember that diagonals of a rhombus bisect vertices, meaning it divides the angle into two congruent parts. Thus, the measure of the angle ROE is 1/2 the measure of angle ROS. Therefore, angle ROE measures 50 degrees. And finally, let us find the measure of angle ESO. Angle RES and angle ESO are consecutive angles of rhombus ROSE, and they are supplementary. Hence, substituting the measure of angle RES, simplifying the results, therefore, angle ESO measures 80 degrees.
You did great! This time, we are going to explore the properties of another special type of parallelogram, which is a rectangle and a rhombus at the same time. Do you know what I am referring to? If you answered square, then you are right. For you to easily remember the properties of a square, just remember all the properties of a parallelogram, a rectangle, and a rhombus. The following are the properties of a square. I hope you get the similarities and differences of the three special types of parallelogram. Now, let us have an exercise. Are you ready? Here we go. That's great. Now, let us apply these properties in solving for a mathematical problem. I know you got it all right. That's all about the 3 special types of parallelogram. I hope you learned something for today. Once again, I am Mr. H, and this is Math Lord and Math Tuto, saying, mathematics is the basic of life. Love, learn, and embrace it for easy living. Bye!